Hello, it's Mrs. Grisafi again, and we are on 4.02 geometry notes today. And last class we talked about side, 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 and side angle side, and we are talking about same thing, triangle proofs, except we're going to talk about 3 new methods, and that's angle, side, angle, 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 side, and right triangle HL. And that'll wrap it up for the different types of triangle proofs that we're going to do. So there's 5 in total. All right, so just like we started last time, I just want to go over kind of what to look for each of these. So the first one we'll look at is right triangle HL. So like it says, right triangle, you have to have a right triangle. And with all 3 of these, again, you have to make sure you have the 3 sets of pieces to make them congruent. In this case, it's not 3 sides or 3 angles. You actually have to have a right triangle and then a pair of hypotenuses congruent and a pair of legs congruent. So first we have to know it's a triangle, a right triangle and a triangle. And then you have to have one hypotenuse congruent to the other hypotenuse. Remember, the hypotenuse is the longest side of a right triangle and it's across from the right angle. And then you have to have one pair of legs congruent. So it doesn't matter which one, as long as it's one pair of sides. And that would be right triangle HL. So let me give these some names here. CAD, and this one is GEF. So this is actually a case where you might look at the picture and say, oh, well, this is side, side angle. And I talked briefly last class about that side, side angle is the one that is not allowed. It's the S, if you do SSA backwards, it spells a bad word. So sometimes we call that the donkey theorem. And the donkey theorem cannot be used because there's 2 possible triangles. There's one exception to the donkey theorem. So if it's ASS or SSA, then the one exception is if it's a right triangle, then the SSA works. So here, this is SSA, but it's a right triangle. So we say, oh, but it's a right triangle, so this is an exception. Our congruency statement here, if we call this triangle ACD, so A is the right angle, so it needs to match up with E, which is the right angle. C is between no marks and 1 mark. G is between no marks and 1 mark, and then F. Then we could have another pair of triangles. So this one's A, B, C. So I'm just going to draw a line between those. And congruent to triangle DEF. And let's say angle B is congruent to angle E. Segment BC congruent to segment EF. And angle C congruent to angle F. Notice I can say one letter because there's only one angle at those points or at those vertices. So these 2 we'd say are congruent by angle, side angle. Again, the order is important, and you'll see why in the next one. But here the side is included between the 2 angles. So if you're not sure what I mean, trace the 2 angles you have congruent in 2 different colors. So there's the 2 marks, the pink angle, and then angle C is in green. So notice wherever they overlap, or if you don't have colors, use squiggly lines. Wherever these 2 angles overlap, that's the side that's included between them. So this would be angle, side angle, and we would take triangle ABC. A is between both no marks, and that would be D would correspond to that. B is the 2 marks on the angle, so that has to correspond to angle E, and then C to F. And then lastly, we'll do the same picture like we just did again, except change up some of the markings. So D, E, F. This one I'm going to give you that angle B is congruent to angle E again. Angle C is again congruent to angle F. But this time, instead of segment BC and segment EF congruent, I'm going to give you segment AC is congruent to segment DF. So notice the difference here by just moving the side. It's no longer included between the 2 angles that we have congruent. Sorry if you couldn't see that. Now it's not included. So this would be angle, angle, side. So here the S is included between the 2 angles. Here the side is not included. But our congruency statement would stay the same for this one. All right, and now let's talk about, just go through a couple different pictures and talk about their congruency statements and whether they're congruent. So tell if the triangles are congruent and why. So using one of your 5 reasons. So side, 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 angle, side, angle, side, angle, 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 side, and right triangle, HL. Those are the 5 reasons you can get triangles to be congruent to each other. And state the congruency statement. So triangle blank congruent to triangle blank. All right, so the first one. Let's do here. Got kind of that bow tie there going again. B, C, D, E, and A. And give you these 2 are congruent. And those 2 are congruent. So again, from this one, looking at the picture, I can conclude I have vertical angles congruent. So this would be side angle side. My congruency statement, if I take triangle BCA, would be congruent to B is between no marks and 2 marks. So E is between no marks and 2 marks. C is between 1 and 2. And then D for that one. Okay, let's look at another one. So this one, let's try this triangle. I'm going to drop a perpendicular down. This is R, S, T, make that A. And so I know those are perpendicular and these 2 are congruent. So looking at the picture, what can you take from that picture still? Because I only have 2 things I know. Well, I know they share this side by reflexive property. I marked that with an X. So now is the angle included between the 2 sides? If you're not sure, trace the 2 sides. When I trace the 2 sides, I get this angle up here, not this right angle down here. So the angle's not included, which means I have side, side, angle. Well, side, side angle is not allowed. So we ask ourselves, is it an exception? And it's an exception if it's a right triangle. So yes, but it's a right triangle. So we can use right triangle HL. So it's a right triangle. You have a hypotenuse congruent to hypotenuse and a leg congruent to itself, which is the leg. And then your congruency statement here, we would take triangle RSA. And here it'd be a good idea to pause the video, see if you can match up to triangle RSA. And hopefully you have TSA there. Okay, let's look at another one. Again, if you're feeling good, pause the video here after you draw the picture and then check back with me. So this one, I'm going to give you that these are parallel and these sides. So actually I'm giving you a parallelogram. Pause the video, see if you can, what you can do with that one. All right, so hopefully you found here your Z. If you needed to trace it, you can. And so this angle would be congruent to this angle. And then I'm going to trace my Z going the other direction. And that gives me in the armpits of my Z, those 2 congruent. I also know that I see the 2 triangles here share a side, so that's by reflexive. So now our 2 triangles are congruent by angle, side, angle, because the side is included between them. And you should have triangle APE congruent to triangle ESA. Now be aware here, if for any of these, if you had PAE, then that would be fine as long as you had SEA. So it's just that A has to go with E, P with S, and then E with A. And let's do one more. Here, if I have And these are parallel to each other. All interior angles. Can mark those. Again, pause the video, try to do this on your own, and then check back with me. So now, and I also have reflexive property in the middle here, so that's angle, angle, side for this one. And that would be triangle. I need to give you some letters here. H-A-T-S. So that should be triangle HAS, congruent to triangle TSA. All right, so hopefully you're getting the idea of how to tell if they are congruent or not and which method. Make sure you know the 5 different ways of proving a triangle congruent. Again, side, 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 angle, side, angle, angle, side, side, angle, and right triangle HL. Let's do a couple formal 2-column proofs. So angle 1 congruent to angle 4, angle CAB congruent to angle DBA. And I want to prove that triangle ABD is congruent to triangle BAC. And here's your picture. Straight line here, go up, and then all the way down, then go up, and all the way down. Again, not drawn to scale. A, C, X, D, B, and then I'm going to put some numbers in these angles so we're all together here. And I think that is our whole picture. And now we'll do statements and reasons. Start with our givens. Angle 1 is congruent to angle 4, and angle CAB is congruent to angle DBA. Let's go ahead and mark our pictures. Angle 1 is congruent to angle 4, and angle CAB, so this whole angle, is congruent to angle DBA, this whole angle. So this one is a little bit more confusing because it's got those, it's all like a lot of triangles I'm looking at, and they're overlapping as well. So a couple things you can do to help yourself here is trace the triangles. So ABD, making that one blue. And let's see to make this other one purple. Hopefully you can see the difference between the blue and the purple on the screen. Okay, so I want to get the blue and the purple triangles congruent. So just by tracing them, you might have noticed that they overlapped completely on the bottom. So reflexive property, I know they're going to share a side there. If you're still not quite seeing it pop out, what might help is to draw them outside of the picture. So A, D, B, and then my purple one over here, B, C, A, and B. So angle 3 is in this purple triangle here. And in the blue triangle, I have angle 2. So that's an angle in each triangle that's congruent. And then angle DBA is part of my blue triangle. That's the full angle in that one, where the purple has CAB as an angle. Oops, forgot my double mark here. All right, so now drawing them outside of the picture, again, might help you just to see you have 2 angles here. And now, oh, wait a minute. We did not know that angle 1 and angle 2 were congruent. Sorry about that. Say this ended up being a lot shorter proof than I thought. So here we actually know angle 1 is congruent to angle 4. We need to get angle 2 congruent to angle 3. We don't have that yet. So we do have the whole angle, and we have a part, the 1, and we have the whole angle over here, and the part that's 4 is congruent. So hopefully you're thinking, if I have a whole and a part, I can use subtraction to get angle 2 congruent to angle 3. All right, so when we use subtraction, you're going to have your 3-step process again. If we can get those 2 congruent, then we also have that reflexive property here. Then we will have the triangles congruent by angle, side, angle. So let's see here. First, maybe you start with your reflexive property. Get that out of the way. Make sure you include it because you get points for that one. So reflexive property of congruency. That gives me a pair of sides. Okay, so now I need my two pairs of angles. So the one pair, we already have the big angle is part of each triangle. So I have that right up here. They're congruent, not equal. So that's a good thing. So that gives me my A. So I still need my other angle, pair of angles. So that's the angle 2 congruent to angle 3. So that's where we're going to use our subtraction to do that. All right, so first let's get 2 and 3 on the board. So I'm going to take the measure of angle CAB minus the measure of angle 1 equals the measure of angle 2. In that same step, I'm going to take the measure of angle DBA minus the part that I know is equal, which is measure of angle 4, equals the measure of angle 3. And that's just like your sum of the parts equals the whole is segment or angle subtraction postulate. All right, 3-step process, remember. So now we have angle subtraction. Now we need the subtraction property of equality. But in order to do that, I need 2 sets of equals. So I need the wholes equal and I need the parts equal. So it looks like I have both of them congruent, but I need them equal to each other. So in the same step, I'm going to make measure of angle 1 equal to the measure of angle 4, the measure of angle CAB equal to the measure of angle DBA. So all I did in step 4 was I took these two and switched them to equality. So you use def of congruency or congruent angles have equal measures would be a sufficient reason as well. Now I have 2 sets of equals. So now I can take the measure of angle CAB right here minus the measure of angle 1. So if I take 2 equals and subtract the same amount from both sides, so subtract equals, I'll get equals. And that is your subtraction property of equality. Again, you can substitute, or you can abbreviate subtraction as subtract. You cannot abbreviate as SUB, as just sub. It's too close to substitution. All right, so now I've got measure of CAB minus the measure of angle 1 equals the measure of angle 2. Measure of CAB minus the measure of angle 1, I can sub that in there. Measure of DBA minus the measure of angle 4, so that's equal to the measure of angle 3. So the measure of angle 2 equals the measure of angle 3 by substitution. Again, you can't abbreviate substitution either. And I need them congruent though, because I need congruent parts to make congruent triangles. And now I have that pair of angles I was looking for. So now they are congruent to each other, 2 and 3. Now I can mark this off from the top. So now I have all 3 pairs of parts congruent, which means I can now say that triangle ABD is congruent to triangle BAC by angle, side, angle. Whenever you write 2 triangles are congruent to each other, it's always going to be one of those 5 reasons that you write across from it. All right, so that's when they get harder, is when you have to use segment or angle addition or subtraction. All right, construct a 2-column proof again. Given angle B is congruent to angle D, and segment AB is parallel to segment CD, prove triangle ABC is congruent to triangle CDA. Here's your picture. A, B, C, D, and then I'm going to draw in my diagonal from A to C. Sorry, that didn't look very nice. It's your diagonal. Okay. Let's write out our statements and reasons. First step is you're given angle B is congruent to angle D. Segment AB parallel to segment CD. Let's mark your picture. I've got angle B congruent to angle D. AB is parallel to segment CD. And again, it often helps to trace your parallel lines with their transversal. So here's a line that cuts through. Find your Z, and then I know the angles inside my Z are congruent. So I haven't written this out in my proof yet, but I can mark the picture just to help myself figure out how I'm going to get these two triangles congruent. So I'm going to drawing my conclusions just in my picture. So now I have two pairs of angles in each triangle, but I need 3 parts. So what am I missing? Well, I see that these two triangles share a side at segment AC, so I can mark that with an X. Now it looks like I have enough to get these two triangles congruent. So I did this in 4 steps. I would pause the video here, see if you can write it out on your own. All right, so we're going to use angle, angle, side to get these two triangles to be congruent to each other. So first of all, B and D, we already have an angle here, so I can mark that off. Now, segment AB parallel to segment CD, I need to conclude from that. So that's where we said the two angles were congruent. Now, to make my life a little easier, I'm going to put numbers in there. So I'm going to call those angle 1 and angle 2. And those are congruent because if two lines are parallel, and it's so important that you have this part of your reason, if two lines are parallel, then alternate interior angles are congruent. If the lines are not parallel, then all interior angles aren't congruent. They're still alternate interior, but they're not congruent. So that gives me another pair of angles. So I need 3 parts. So now your last part, hopefully, was that you got segment AC congruent to itself by reflexive property of congruence. And now that gives me my 3rd pair of congruent parts. So once I have all of these crossed off, now I can say triangle ABC is congruent to triangle CDA by angle, angle, side. Again, when you write your congruency statement, it should always be one of those 5 reasons. All right, and number 3. This will be the last one for us for today. So segment DEA is perpendicular to segment AB, and segment CB is perpendicular to segment AB, segment AC congruent to segment BD. Prove triangle ACB congruent to triangle BDA. And here's your picture. Call this D, B, A. And draw in our diagonals. I'll try to pay more attention to where I'm drawing. That's segment 2 there. All right, and write out your 2 columns. Write out your given. Segment DA, perp to segment AB, segment CB, perp to AB, segment AB, and segment AC, congruent to segment BD, and mark your picture. So I've got segment AC congruent to segment BD, and we've got DA perpendicular to AB, so I mark that with that box. Segment CB perpendicular to AB down here. And we're trying to prove ACB, so I'm just going to put that one in blue, is congruent to BDA. So you have overlapping triangles, so if it helps you, you can draw it outside the figure. Here, I also noticed after I traced those in 2 different colors that they overlapped on segment AB, so I've got reflexive property. Now that you've marked your picture, I'd like you guys to take a minute to try to figure out, pause the video, and decide what method are you going to use to get these to be congruent to each other. All right, so hopefully you decided on right triangle HL. So you might have seen here that you had a right triangle in each, and then you have the hypotenuse that was given right here, congruent in each one. And then with your reflexive property, that gives you a leg congruent in each one. The hard part about this one, where I often have to take points off for students, is that they forget to state it's a right triangle. So you still need three things. You need the right triangle, you need the hypotenuse congruent to hypotenuse, and the leg congruent to a leg. So far, we have segment AC congruent to segment BD. That is the longest side of the triangle, which is our hypotenuse. So I can cross that right off. It's the only pair of congruent parts that I have at this point. Now I have some conclusions that I can draw, though, from my givens. So I know that segment DA is perp to segment AB. Again, so important that you conclude from all of your givens that you possibly can. So helpful, because even if you don't know how to do the proof, you could still potentially get quite a few points for the proof if you just concluded from each given. So segment DA, perp to segment AB, we know perp lines give us right angles. Remember, though, you cannot write angle A. You must write three letters. You also can't even give that a number because there's two parts inside of that whole angle. So angle DAB is a right angle. We also know segment CB is perp to segment AB from the second line here in our given, that we could say angle CBA is a right angle. The reason? Perp lines form right angles. If you don't know that, that means you're not studying those boxes enough. You need to have those memorized. So please go back, find it in your stream or in the classwork on Classroom, and print it out if you can, or I've printed them all out. So at this point, you guys should have a copy of them, a hard copy. So cover them up, quiz yourself, have your parents or a sibling or a friend quiz you on them. You need to have those memories memorized, or you can make flashcards too. That sometimes really helps students. All right, so now we have that it's a right angle. We don't have that it's a right triangle. Big difference here. We just have a right angle. In order to have a right triangle, you need a right angle inside of a triangle. Well, good news is we have that. So this is the step right here that students forget. So don't forget this step right here. So I'm going to say triangle. Remember difference. Here we had angle DAB. Now I have triangle DAB and triangle CBA are right triangles. The reason? If a triangle has a right angle, then it's a right triangle. So keep that difference between an angle and a triangle. Triangle is the shape with three sides. An angle only has two rays that make it up. All right, so now I have two right triangles. And again, that's the part that people forget. So really important that we have that. So now we just need the leg, and that's coming from your reflexive property. So segment AB congruent to segment AB by reflexive property of congruency. And that gives me my leg, can cross that off. Now that I have all three parts met, again, two right triangles, a hypotenuse congruent to a hypotenuse, and a leg congruent to another leg. Once we have all of those marked off and they're all congruent, besides the right triangles, those you just have to state, we can say triangle ACB is congruent to triangle BDA. And I haven't made a big deal of matching up your corresponding parts yet because we've been given them. But when we talk about CPCTC, which is corresponding parts of congruent triangles are congruent, so we take our proofs one step further, you're going to have to come up with that congruency statement on your own. So good idea to be double checking it at this point, but typically if they give it to you here, you can just use that same one. And our reason is right triangle HL. You will see that, especially if you're looking at a Regents exam or Regents question, and I'll accept this as well as HL as opposed to right triangle HL. I like to call it right triangle HL, so it's a little extra reminder that you need to state their right triangles first and then do the HL as well. All right, and that is it for us today. So that wraps it up for the 5 different types of triangle congruency proofs. Let me know if you do have any questions or you're unsure if a proof you did maybe works or a different order, anything like that. I hope to see you guys soon. I hope you're staying healthy, and pie out.